In this video, we're going to look at the derivatives of inverse trig functions. And as with all my videos, if you want to skip through some of it, I'll have links to the times of various slides in the description down below. So first off, I'm going to look at these three inverse trig functions. And just to sort of reiterate some information here, when I write this sine -1 of x, this is not sine of x to the negative first, or this sort of 1 over sine of x. This is instead arcsine, the inverse sine of x, or saying this means the arc or angle whose sine is x. And so the derivatives of arcsine of x, well, the derivative of that will be 1 over the square root of 1 minus x squared. The derivative of arctangent x is going to be 1 over 1 plus x squared. And the derivative of arcsecant x is going to be 1 over absolute value of x times the square root of x squared minus 1. And if I had to say which one shows up most often on the AP test, you can almost guarantee that you'll have at least one problem with either arcsine or arctangent. Very rarely, I can't think of the last time I've seen on a released exam that they've used arcsecant. It's a little bit trickier. Next up, we'll prove all three of these. And again, if you don't care about proofs, feel free to skip down to the first example from the description below. So, in order to prove this, I'm going to first say, alright, let y equal the inverse sine of x. And if y is the inverse sine of x, then I can flip it around and say, okay, that means the sine of y must equal x. And from here, I can take the derivative with respect to x of both sides. Let me do that. So the derivative with respect to x, and using the implicit differentiation, the derivative of sine is cosine of y. But the y and the x aren't the same, so I have dy dx. And the derivative of x is 1. If you do not understand implicit differentiation, I have a video up on that already. I'm going to solve this for dy dx by dividing both sides by cosine of y. And, okay, great, I found dy dx. Unfortunately, this is in terms of y, and my original function was dealing with x, so I want to get back to that. So I know y is arcsine of x, so this will be 1 over the cosine of the inverse sine of x. And now I have this little problem. If this were the cosine of the inverse cosine, then they would in some way cancel out. There's a little issue with that, but it's not. It's the cosine of the inverse sine. So what I'll do is this. I'll make a little triangle. I'll mark an angle as y. And in here, so I'll make it a right triangle, the arc whose sine is x, we know that sine is going to be the opposite over the hypotenuse. And if that's equal to x, I can make the opposite x and hypotenuse 1. It's not the only option. And I could do something different. I could do x squared and x. But this will be the simplest option. Well, now I need to find the cosine. So I need to find the cosine. Cosine is adjacent over hypotenuse. And the problem is I don't have the adjacent side. So let's call this a for adjacent. And I'll do a squared plus x squared equals 1 squared. Subtract x squared from both sides. a squared equals 1 minus x squared. Take the square root. A equals the square root of 1 minus x squared. So that'll be the square root of 1 minus x squared, which means that the cosine of the inverse sine of x will be adjacent over hypotenuse, which is just going to be the square root of 1 minus x squared. And there we have it. Now there's one possible issue that comes in when we get to secant about the sign, S-I-G-N, positive or negative of these, but for now, this cosine will always be positive regardless of what x we have because of the way arcsine works. Alright, this one I'll go a little bit faster, same idea. So I will start off by letting y equal arctan of x. And if I don't have the rule for arctan of x yet, I flip this around and say, okay, that means the tangent of y equals x. I take the derivative with respect to x of both sides. And I get secant squared y dy dx equals 1. Divide both sides by secant squared y. Dy dx equals 1 over secant squared y. I know that y is inverse tangent of x, so that will be 1 over secant squared of the inverse tangent of x. And now I make my triangle. And again, I'll go a little bit faster. It's the same idea as the last one. This is the arc whose tangent is x. Tangent is opposite over adjacent, so I'll make this x and this 1. I'll do the Pythagorean theorem. 1 squared plus x squared equals hypotenuse squared. So this will be the square root of 1 plus x squared. And now I'm going to figure out what secant squared is. So secant squared y. And in order to find that out, well, let me figure out what secant of y is. And I'm like, okay, well, how am I going to find secant y? Well, let me start by finding cosine of y. So cosine is adjacent over the hypotenuse. So that's going to be 1 over the square root of 1 plus x squared. The secant is the reciprocal of cosine, which will then just be the square root of 1 plus x squared. That means secant squared will be just 1 plus x squared. The square root and the squared are going to cancel. So that means that dy dx, the derivative of arctangent in this case, will be 1 over 1 plus x squared. Alright, same idea for this one. There's a little trick at the end that comes about with this absolute values. We'll talk about it. So I'll start by letting y equal arcsecant of x. If I don't have a rule for arcsecant yet, let me flip this around and say, okay, that means secant of y is equal to x. Take the derivative with respect to x of both sides, and I will get secant y tangent y dy dx equals 1. Divide both sides by secant y tangent y, so dy dx equals 1 over secant y tangent y. And in this case, I don't want y's, I want x's, so I'll replace this with 1 over secant of what y was, which is arcsecant of x, times tangent of arcsecant of x. And now, here's what happens. It's a little bit weird. So, the first one, I have 1 over, and the secant of the arcsecant is, unless we're off on strange portions here, or outside of the range of some of these things, the domain, this should be x. We'll make our triangle. And again, I'll go a little bit quicker here. So we want to figure out the arc whose secant is x. Secant is the reciprocal of the cosine. Cosine is adjacent over hypotenuse, so this will be hypotenuse over adjacent. Doing the Pythagorean theorem, 1 squared plus opposite squared equals x squared. Subtract 1 from both sides and take the square root, and we get the square root of x squared minus 1 there. And now I want to find the tangent. So the tangent looks like it's just going to be square root of x squared minus 1. But here's the kicker, here's the rub, all right? The secant of arcsecant can be positive or negative, depending on the value of x. The tangent also can be positive or negative, but here's the problem. X can be positive or negative, but the square root, the way we have it written, is always positive. Really, when I got this 1 plus opposite squared, that's not a 0, equals x squared, and subtracted 1, opposite squared equals x squared minus 1, at this point, I should include a plus or minus. But the interesting thing is, this works perfectly so that when secant is positive, tangent is positive. When secant is negative, tangent is negative. And a positive times a positive is positive, a negative times a negative is positive. So regardless of what x value I get in here, multiplying these two together will give me a positive. This is already positive, so I just toss in the absolute values to make sure that the entire denominator is positive, and we get our answer. If people desperately want to see more and this explained more thoroughly, comment down below. I can make a video all about this portion. Alright, finally examples. This is where it gets easy. Alright, so I just need to remember the rule. If I want the equation of the line tangent, I need the point. To find the point, I'm going to find y of the square root of 3, which is going to be the inverse tangent of the square root of 3. And knowing from the unit circle, okay, tangent is going to go, let me think this through, it's going to have the same domain, or the arctan will have the same domain as, output, as sine here. And tangent is root 3 up here, where the y value is bigger than the x value, so that's going to be pi over 3. So I have the point, root 3 pi over 3. Now I need the slope, and so I find the derivative of y with respect to x. Well, that was just our formula. The derivative of arctan is 1 over 1 plus x squared. But x is root 3. I need to actually get the numerical slope. So dy dx, evaluated at x equals root 3, will be 1 over 1 plus root 3 squared, which is, root 3 squared is 3, plus 1 is 4, 1/4. And so my final answer is y equals 1/4 x minus root 3 plus pi over 3. But now you might be saying, hold on, there's more than 3 trig functions. What about the others? Well, if you have the first 3 memorized, these next 3 are easy. And here's the idea. First, let us recall that, make sure I'm doing this in the correct order. Okay, so we know that the sine of pi over 2 minus x is going to be cosine x. And we know that the, let's do tangent. So the tangent of pi over 2 minus x is going to be cotangent x. And we know that the secant of pi over 2 minus x is going to be cosecant of x. If I were to invert these, try to get outside of it. So if this input has a power of 2 minus x, when I go to the inverse, the output is going to have the pi over 2 minus arc sine of x. Same thing here. So when I'm dealing with tangent and cotangent, the input had pi over 2 minus this x. When I go to the inverses, the output has to have the pi over 2 minus. Same thing with secant. So pi over 2 minus x as the input, so I have a pi over 2 minus arc secant of x equals arc cosecant of x. And from this directly, we get that the derivative with respect to x of arc cosine of x will just be 0, so I take the derivative of this side, 0 minus the derivative with respect to x of arc sine of x. And so that's just going to be negative 1 over square root of 1 minus x squared. And the derivative with respect to x of arc cotangent of x will just be the negative, the opposite of the derivative of arc tangent, which is going to be negative 1 over 1 plus x squared. And the derivative with respect to x of arc cosecant of x is going to be the opposite of the derivative of arc secant. Okay, so if you have the first three memorized, you go to their cofunctions, and you have the opposites. Last example. So just evaluate the derivative here. The outer function is arc cosine, so I start off by taking the derivative of that, which is the opposite of the derivative of sine, which was 1 minus the input squared. The input in this case is x squared minus 5x. And since I have an inner function here, I need to do chain rule, so multiply this by the derivative of the inner function, which is not x squared, 2x minus 5. And I can clean this up a little bit by multiplying this into the numerator. And that will give me 5 minus 2x, the negative changes both their signs, over the square root of, that should be squared, 1 minus x squared minus 5x squared. And I don't see any real reason to expand x squared minus 5x squared. You can. If I knew it were going to make a perfect square out here, I'd do it to reduce it down, but it's not going to. Alright, I hope this helps out. Feel free to comment below if you do have any questions.